this equation has x squared and negative y squared. So before we start drawing, can we understand the shape first? When I see positive x squared, negative y squared, this is a hyperbola. Before we draw, we should always aim for standard form. Standard form looks something like that. I just write here so that we can take reference. We want to aim for such an equation. Always go to standard form. And how to do standard form? To convert equations to standard form, complete the square for both variables. Because you want to end up with something squared on both. So let's start solving. I will take this equation, but I will be grouping up the x together. So we have 4x squared minus 8x minus y squared plus 3 is 0. To complete the square, I need to factorize out 4. Let's complete the square. And I get it expanded. My constants, I'm going to move it to the right hand side. If you observe the equation of the hyperbola, you will notice that there should be no coefficient in front, but you can have numbers in the denominator. Therefore, for this equation, it is not okay for you to leave 4 there. If I want to make it standard form, it should be pushed down to the denominator. When I push it down, it becomes 1/4, but can I immediately write as a squared term? Okay, we want to leave the denominators as a square as well. Okay, 4 moved to denominator is 1/4, and 1/4 is half squared. The value y, we want to present in a similar manner, such that I can see the center, so I write as a y minus 0 square. If there is no denominator, means it's 1. So I can also write as a 1 square. Okay, just ensure that we can see also that the right hand side has become 1. This now allows us to get asymptotes. We plan for asymptotes first before we get the graph drawn. Remember, it's that 3 steps for asymptotes. Remove 1, remove squares. Okay, so if I do that, this is what I get on the left. Immediately, I will move the y term to the right. There will be a plus minus because of the removal of the squares. And I would like to write out the equations explicitly. These are the 2 equations. Let's draw it out together. I will guide you on the steps. So help me set up a big graph. You may want to leave some gaps at the top so that later we can write more things about the part 2. Just leave a little bit of gap here. Okay, otherwise, let's get a big axis drawn up. The steps to solve are as follows. If you want to get the shape nice, we follow these steps. Number one is always set up your asymptotes. And when I set up my asymptote, think of these 2 points. Your asymptotes surely will pass through its own y-intercept. So we will be marking out this point onto the graph. Okay, y-intercept of asymptote. And also center of hyperbola. Okay, let's put it in. What is the y-intercept? Asymptote y-intercept is -2 and 2. So let's mark it in 2. Okay, roughly to scale. -2 below. Where is the center of the hyperbola? Center comes from, you set the numerators to be 0. So if this numerator is 0, we get 1, we get 0. So the center is maybe somewhere here. Center, let me give as a coordinate. Center is an important point that we should mark out as a coordinate nicely. Asymptote is a straight line that passes through these 2 points. It will pass through the center and its y-intercept. So we will connect up in dotted lines, please, for asymptotes. That's one asymptote. The other asymptote will pass through the other y-intercept and also that same center. Before we forget later on, let's label in the asymptotes equation as well. And number 2, we want to check for the orientation of your hyperbola. Orientation means, is it a horizontal or is it a vertical hyperbola? Remember, we observe where is the plus. And my plus is located at x squared. So because it's located at x squared, I will know that the orientation is a horizontal one, a left and a right portion, where this is the center. And number 3, last. This one last position will help you draw in the graph nicely. I need to get distance from the center to your vertex, which in our case, it is this horizontal distance here. Okay, center to the vertex. If it's an x distance, you look at the value below your x. So below x, it's half. So distance is half. Okay, so we can mark out, we go back to the graph, I mark out half a unit x distance to the left of the center. It happens to be on the axis. Half a unit to the right of that center. And can I label this also as a coordinate? For centers, we also put, for vertices, we also put as a coordinate. So your graph must pass through this vertex. And we know that it's left and right oriented, so I can now start to draw. Just make sure that your endpoint is very close to the asymptote. And then it looks like it's like a turning here. And we continue to go downwards. this way. So we are done. What you may want to do last will be we get our equation labeled in.